Securing APIS, Authentication and Authorization Techniques. Title: Securing APIS, Authentication and Authorization Techniques. Introduction. In today's digital landscape, application programming interfaces, APIS, have become a critical component in enabling seamless interaction between different software systems. However, with this said reliance on APIS comes the need for robust security measures to protect sensitive data and prevent unauthorized access. Authentication and authorization techniques play a vital role in securing APIS and ensuring the integrity of information being exchanged. This article aims to explore various authentication and authorization techniques that can be employed to fortify API security. 1. Understanding authentication. Authentication is the process of verifying the identity of a user or system, ensuring that the claimed identity is genuine. By implementing strong authentication measures, API providers can ensure that only authorized users or systems gain access to their APIS. Here are some commonly used authentication techniques. A. API keys. API keys are unique credentials issued to developers or users to authenticate their access to an API. API keys can be passed as headers, query parameters, or within request bodies. They are relative. Why easy to implement but lack the granularity and flexibility offered by other authentication methods. B. OAuth 2.0. OAuth 2.0 is an industry standard protocol widely used for API authentication. It enables delegation of user authentication to a trusted third-party service, Authorization Server. C. OpenID Connect, OAuth. Built on top of OAuth 2.0, OpenID Connect adds an identity layer that allows clients to retrieve verified user profile information using a standardized set of claims. OAuth simplifies user authenticate. Ion facilitates single sign-on and offers flexible authentication methods, such as username/password, social logins, and multi-factor authentication. 2. Ensuring authorization. Authorization comes into play after successful authentication, determining what specific actions or resources a user or system can access. Robust authorization mechanisms prevent unauthorized users from carrying out sensitive operations. A. Role-based access control, RBAC. RBAC is a widely adopted authorization model that assigns user roles with corresponding permissions. Users are granted access to resources based on their roles, simplifying permission management and ensuring a granular level of access control. RBAC allows organizations to define access policies based on a wide range of attributes such as user location, device type, time of day, etc. C. JSON Web Tokens, JWT. JWT is a popular token-based authorization mechanism. It encodes user information and other details into a digitally signed token that can be passed between systems. JWTs eliminate the need to store session data on the server side, making them scalable and efficient. 3. Best practices for API security. Beyond understanding the authentication and authorization techniques, it is essential to follow best practices to ensure robust API security. Here are some key points to consider. A. Transport Layer Security, TLS. Always use TLS, HTTPS, to encrypt communication between clients and servers. TLS ensures data confidentiality and integrity, preventing eavesdropping and tampering with API requests and responses. B. User input validation. Implement strict validation mechanisms to sanitize and validate user input. This prevents injection attacks, for example, SQL injection, XSS, and protects the API from malicious payloads. C. Rate limiting. Enforce rate limiting mechanisms to prevent abuse, protect against DDoS attacks, and ensure fair usage of API resources. D. API documentation and education. Clearly document API policies, authentication methods, and authorization flows for developers and consumers. Regularly educate users about secure coding practices and potential security risks. 4. API hardening techniques. In addition to authentication, authorization, and best practices, there are additional techniques that can be employed to harden API security. These techniques add an extra layer of protection, making it even more challenging for malicious actors to exploit vulnerabilities. A. Input validation and sanitization. Apart from user input validation, it is essential to validate and sanitize all incoming data, including headers, query parameters, and payloads. This prevents common attacks such as buffer overflows, command injection, and cross-site scripting. B. Output encoding. Always encode output data to prevent injection attacks and protect against cross-site scripting. By encoding output in a way that disarms malicious scripts, potential vulnerabilities can be mitigated. C. API secret management. API secrets, such as passwords or cryptographic keys, should be securely stored and managed. Use secure storage mechanisms, such as a secure key vault or encrypted configuration files, and never store secrets in plain text. D. Threat modeling. Performing a thorough threat modeling exercise helps identify potential threats, vulnerabilities, and attack vectors. By understanding the threat landscape, organizations can proactively address security weaknesses and implement appropriate countermeasures. 5. API security testing. Regularly testing APIs for security vulnerabilities is crucial to identify and address potential risks. Here are some recommended testing techniques. A. Penetration testing. Conducting penetration tests simulates real-world attacks, aiming to exploit vulnerabilities in APIs. By identifying and remediating these vulnerabilities, organizations can ensure the security of their APIs. B. Fuzz testing. Fuzz testing involves providing invalid, unexpected, or random data inputs to an API to identify potential input validation flaws or security vulnerabilities. It helps uncover bugs and vulnerabilities that may not be caught through traditional testing.